Hello students, we are now discussing question number 94 of KVPY SX 2021 paper. This is fourth question of part 2 of physics. Let's see what the question says. So it says that according to Poiseuille's equation, the pressure drop per unit length required to overcome viscous forces is given by this expression, where R is the radius of the cross section, V is the fluid velocity, N is the coefficient of viscosity. Now the question says that a capillary tube of radius A is dipped in a liquid of density rho, surface tension T, coefficient of viscosity eta. The liquid starts rising in it so that its height is a function of time. So if we draw a capillary tube here, assuming that it has been dipped in a liquid, okay, that any general instant the height is h, we are assuming, and this is further increasing, like this h is going up. Okay, now the resulting rate of change of momentum of liquid column in the capillary. So the liquid is rising up, so the liquid in this capillary is moving, so we have to write the rate of change of momentum. Now recall from Newton's second law that rate of change of momentum is also equal to the net force acting on the body. Okay, we have to take the upward direction to be positive. So if I have to draw a figure of the liquid which is present in the capillary, then I will draw a figure like this. So first of all, notice this: the meniscus of the liquid will be hemispherical. The contact angle has been given too close to zero, so the meniscus will be hemispherical, and the forces acting here would be an upward force will act on the periphery of this hemisphere. Okay, so that will be the force due to surface tension, and it will be given by T into 2 pi A. So this force will act. Apart from this force, what kind of force can we expect? There will be a force of atmospheric pressure, like force because of atmospheric pressure on this surface, and this will be equal to, I'm drawing the net value of this force, this will be equal to the atmospheric pressure into pi r square. We'll take the area of projection while computing the contribution in force due to this pressure. Apart from this, we'll have the pressure here also, like the liquid in the tube and the liquid here, these two are in contact. So again, the pressure at this level will be equal to atmospheric pressure, so you will have an upward force of P naught into pi r square. And apart from this, we'll have two more forces. One, the weight of the liquid, so I'll just simply write it as W right now, or maybe we can just write the value of W also. So W will be equal to density into volume. Volume will be H into pi r square, so this becomes M into G. So this is the weight, and apart from this, we are assuming that the liquid is moving up, so there will be a viscous force opposite to the velocity of the fluid, so there will be a downward force which is Fv. And how do we write Fv? To write Fv, we have been given this formula, so we are going to write it as 8 into eta into V. V is what? V is y dot or dH by dt divided by r square. Now this is the pressure, so we'll multiply it with pi r square. So this becomes force, but this becomes force per unit length. So the length of the liquid column is h. So now this becomes force. So after having written all this, we have to now write the net force. So I'm writing net force in the upward direction. So how do I write that? The net force in the upward direction. So I'll start writing the upward forces first. So upward we have two forces. In fact, these two get cancelled. So upward we have only one force, which is 2 pi A into T. And I'll subtract the downward forces from it. So downward forces are Fv and downward forces W. So I've considered this, and these two get cancelled. We drew 5 forces, 2 of them got cancelled, and 3 we have considered here. So I think we can just substitute the values now. So Fv is how much? It is 8 eta V, 8 eta V pi h, r square gets cancelled. Okay, and then minus of rho h pi r square g. So this is the net force, and now we have to compare it with the expression given. So pi a square rho gh, do we have something like this? So r is a basically, so pi a square rho gh. So this part we have got here, and whatever is left will be called as f. So whatever is left is this. So this entire part becomes f. And here we are getting a negative sign, here also we have a negative sign, so that ensures that we have done everything okay. So the value of f that we are looking for is 2 pi at minus 8 eta v pi h. Let's see whether we have an option like this or not. So I see two options with 2 pi ta, and then one with minus sign, one with plus sign. dH by dt is nothing but V, so we will go with option C. So for this question, option C should be the correct one. So I hope you enjoyed the solution to this question, guys. Do inquire about Eklavya program if you are not aware of it already, and do scan this QR code. All the best, student. I'll see you in the solution of next question.